Hi, I'm Shane Shoemaker. I'm with FESTO, and I've been supporting PennAir for the past 3 years. Today, I'm going to be talking about our newest electric actuator, the ELGD. Here's an example of the different versions. We have a wide format. We have our standard format, also tooth belt, and then we also have a ball screw format. The ball screw I have here is for our standard variant, but we do also have a wide ball screw version as well. Here's examples of some of the extrusions. So this would be the wide body extrusion. And then this is our 80 frame size, which I don't have here on the table. And then our 60 frame size, which these two are the 60 frame size. In the future, we'll be having a larger, all the way up to 220 for the wide. And then we'll have down to a 30 millimeter frame size and up to a 160 millimeter frame size for the standard variant. The tooth belt version goes as long as 5 meters right now, and then 2 meters for the ball screw variant. As far as other options, we can get an extended slide. So this ball screw version has our extended slide versus a standard slide. So that's great if you're trying to translate a large mass and you're worried about moments from the inertia of the mass you're moving. The actuator also has a nice cover cap. So this is a stainless steel cover cap. It's very thin, as you can see. And then it's also magnetically coupled to the actuator. So it's not a perfect seal, but it does give a good seal to keep dust and debris out. I mentioned earlier that we have a standard slide and an extended slide. We also have options where you can add an additional slide. So if you have a really wide footprint, and you want to have even more moment capability, you can add an additional slide, or even just physically, if you have a long part that you're mounting to the actuator, that'll just give you more balance as you translate the load. Typically with the U-style extrusion like this, you'll see a guide rail in the middle for the bearing mounts. And what we did is we essentially split the guide rail in half and separated it onto each side. So this here is one side rail, and then there'd obviously be another one symmetrical on the other side. And what this does is it just makes for a much wider footprint for holding, so we can handle significantly higher moment loads than we would have been able to do with the same size actuator with the guide rail in the middle. So this will save on cost because you can maybe size down an actuator, and then also space. So we'll be able to use a smaller actuator that will take up less space. When it comes to motor mounting, we have lots of different options. For the ball screw, we have the connection on the one side, but you can orient the motor any way you want, which makes it great for being able to, direct the cable for the motor any way you would like. On our tooth belt version, we have one end cap that is compatible for mounting a motor, but the actuator is symmetrical. So you can flip it if you need the motor, maybe like, let's say on my left side or right side, it's totally symmetrical. You can also mount the motor on this side of the end cap, or if you remove this cover cap, you can mount the motor on this side as well. So although you can only mount to one end cap, because the actuator is symmetrical, you can essentially put it on either side of either end cap. The repetitional accuracy on the actuators for a tooth belt is 40 micron. And then for a ball screw, which we're typically using for a high force or a high repeatability application, can get as low as 10 microns for repetitional accuracy. Environment is super important when you're deciding which actuator you want to use. Using this covered cap, we've essentially enclosed the actuator. The cover strip is magnetically linked to the bottom of the carriage and also the sides of the extrusion. Typically when an actuator will slide with a cover cap like this, you'll sometimes see a buildup at the end of the actuator where it's sliding materials and pushing them to the end. We wanted to avoid that, and so there's actually a space between the top of the cover strip and the bottom of the slot it slides through in the carriage. So this allows small dust and debris to just not be dragged all the way to the end of the actuator, and you eliminate the buildup. One thing this cover strip also allows for is to keep particles in or to keep particles out of the actuator. So it's not a fully enclosed system, but what you can do is use a purge port. So you can just thread a pneumatic fitting there, put in a tube. If you are in a clean room environment, you would want to run a vacuum. So you would keep any dust and debris contained inside the actuator. And then for like a dirtier environment, you'll want to keep dust and debris out of the actuator. So you would then run positive pressure. And with this cover strip, you would get very effective results. These actuators are compatible with FESTO motors and drives, but we've obviously made them compatible for third-party motors and drives as well. And we have a big variety of axial kits and 90-degree kits that would allow you to mount third-party motors to these actuators seamlessly. For sizing, we have our electric motion sizing tool. This is a very critical tool that we use almost daily at FESTO. So it allows us to enter application parameters, so speed, the length of travel, and then also one critical one is the moment load. So we need the center of gravity of the mass that we're moving. We input that data into electric motion sizing. That will generate our report and it will recommend an actuator. Once you've entered your mechanical and electrical data into electric motion sizing, you'll be able to take the system that's populated and pull motion profiles, commissioning files for your motor and drive, as well as CAD models and a bill of materials. You can even select accessories as well, which makes mounting a breeze. Thanks for listening. If you have any questions about the ELGD, feel free to reach out to your PennAir rep.